So I'm going to talk about some stuff that we've done at Planet Labs. I'm going to start a little while back and just give a two-slide intro to the company. Many of you probably know who it is, but it's going to set the stage. So we are a satellite data and imaging company, and we've launched a lot of satellites and we operate them. This is a funny view. They are moving. This is old, several years old, but we have launched a lot of satellites. These are all ours in orbit. Different constellations with different crossing times. They in a kind of string of pearls configuration. This is in an Earth-fixed frame, so it looks like the stars are rotating and the satellite orbital planes are rotating and the Earth is fixed. Obviously, that's just a frame of reference thing. This is just showing you over the course of one day, sort of the orbital tracks of our satellites. It's approximately how it is now. They almost all go almost polar. They don't actually cover the secret hole in the middle of Antarctica that all the saucers are going in and out of, but we deliberately avoid that place. No, we do avoid it because most people aren't interested in buying data about the middle of Antarctica. So, but we cover a lot of the world. So here's a typical day's coverage of the images downlinked by all of our satellites. Now, each little pixel in this image that you can see, each little tiny square is a 50 megapixel image in 8 spectral bands that's brought down by our satellites. I'm mostly talking about our monitoring constellation here of about a little over 200 satellites. So in one day we get most of the Earth on most days. Now a lot of the Earth is covered by clouds, but not all of it. And sometimes we miss a strip and then we get it the next day. But it's over 10 terabytes a day of imagery. And that was what we called Mission 1, which was envisioned by the company founders approaching like 15 years ago. And it did take a number of years, not quite 10, to complete Mission 1, where we're getting daily coverage of the Earth. We've launched over 600 satellites, which is more than anyone except for SpaceX, our own satellites. So we have the largest Earth observation constellation in orbit compared to any country or company by far, and the largest constellation of any kind in orbit except for Starlink. As I said, the constellation I'm talking about here, we have a bunch of high-res satellites also, but they don't cover the whole Earth. This constellation I'm talking about captures at about 4 meters per pixel in 8 bands, visible in near-infrared. Red, green, blue, a bunch of other colors. We capture about 90% of the land on Earth every day, including the territorial waters of all nations. But we don't capture all of the open sea every day. And we downlink up now close to 20 terabytes a day of imagery from our satellites. And this sets the stage for, we've been doing this for 10 years, getting better at it. But so this gigantic amount of data every day for 10 years sets the stage for what our founders and CEO called Mission 2. It was originally called Queryable Earth when he talked about it at TED many years ago, but since that name got out into the wild, we couldn't trademark it. So now I'm trying to get the Queryable Planet to catch on, because I think that would be a great name for a AI Earth observation question answering systems made by Planet. So the idea is to use AI plus satellite imagery as kind of a source of truth about the Earth. Like, we can all argue for LLMs where it's getting its training data. Is it getting it from Fox or the New York Times or Reddit or who knows what? But if you're getting training data, if you will, or data to feed your AI by cameras that are in orbit around the Earth every day, as long as no one's tampering with that, it's kind of a little less argument about subjectivity. So the 10-year vision for Mission 2, from 10 years ago, roughly, when he did his TED Talk on this, I think, approaching 10 years ago is when he first surfaced it in private with us. Will was like, AI is going to get so good that you're just going to be able to ask the AI questions about the Earth and feed it the satellite data, and it can just answer your questions. It'll do anything. And I was like, oh man, you're dreaming. AI is never going to be that good. So now, fast forward these years, and about 2 years ago, I started to see that was actually a real vision with some actual merit. AI probably was getting that good. I didn't see it as fast as Will did. So it's getting very close, this idea of a thing you can ask a system which takes all this data in from our satellites and others too, and where you can ask it questions about the Earth. We're getting very close, and I'm hoping to show you some demos either at the end of this talk or if I run out of time at your leisure after this talk. Demos of this thing that's kind of actually works at this point. So a little bit about the engineering. I've been involved in a very small engineering team that's gotten this AI part to work. There's a big team that got the whole system to work, obviously with the satellites and ground stations and the image pipeline. We use everything that there is to use practically in Google Cloud, Google Batch, Google Dataflow. We use BigQuery, we use Vertex AI, we use Spanner. These are technical systems that are scalable systems that Google makes that we've had to incorporate all of them into this AI system, Queryable Planet system, change search detection system. It has various names. Planet Chat. What is the name we call it, Mikhail? No, we don't call it that. Planet View, yeah. There's various names for various components, but they're all kind of tied together now. But I will say this, I've learned so much about Google's offerings for scalable model calling and vector database search. I know as much about these things as anyone at Google, I think. Sometimes I think more because they have so many products that do kind of the same thing in different ways, different functionality, different costs. It's really it's really amazing. We use multiple multimodal large language models as part of this project. We use Claude and all the versions of Gemini that have been released. So what is it like? The way we do it right now is we break our planetary image into little tiles because vision language models like little tiles better than huge images. We get about 260 million tiles per day embedded, and that's just the RGB imagery. The tiles are about 256 pixels square. We make vector embeddings using multiple models of every one of these tiles, using different vision language models, which are tuned for remote sensing, but interestingly enough, not tuned on our data in particular. And one of the paradigms we use is we might start with a vector search in an embeddings database in order billion embedded tiles, asking to see certain things. We might embed a text query into the same space as the images are embedded into, receive neighbors from this embedded text query. We might take sample images and ask for similar images. We might refine with relevance feedback, which is kind of like thumbs up, thumbs down kind of things to refine these queries. And we might refine with a full-on multimodal large language model. Okay, but another very interesting thing about this is we're mostly interested in searching for change, so we're not looking for an image of this or an image of that. We're looking for a place on the Earth where the state has changed from something like this to something like that. And we've now got it so that we can search the entire Earth for change from time point A to time point B in about 1 second. The entire Earth with 250 million tiles. So now it would be time for some demos, but Allison has informed me that I've run out of time. I just want to say that this is the first time we'll ever be showing demos of this in public. A big team did the big project of all the satellites for many, many years, getting it to work, getting the data down, getting the data in GCP buckets, keeping the lights on, keeping the money coming in so that we could do this research. We have a very small team. Mikhail Klassen over there, myself, about 5 others that have done this in the last year and a half or so. So I'm going to ask you, please don't post the demos. Let Allison and Foresight post it in their own time so that I can go back and try and get forgiveness for having told you all this.
Well, I think instead of doing a Q&A, would everyone agree that we want to see a demo? All right, let's go.
All right, so let's see.
No photos and no videos of this.
Yeah, thanks. So I'm going to show you just a little part of it. I call it Big Queryable Planet. It's something that a bunch of us have worked on. It's easy. I wrote a lot of the UI, so it leaves something to be desired. Let's put it that way. But it does the job. Okay, so it shows you a whole bunch of little image chips before and after. And then you can make queries. Now there's 260 60 million image chips back here. So I'm going to ask for, oh, I've got a query already in here. But again, none of this data was shown as training data to these models. None of this data was captioned. None of this data was classified. None of this data was labeled. It was just embedded. Well, this is, how about many, I don't want to do solar panels. I'm going to go from empty desert to blue buildings. What was that? Oh, builders. Oh, it's pretty tolerant of typos. I have no idea. Many blue buildings. So much for voice recognition. Okay, so it's gonna, assuming everything works, the internet and all these things, there we go. So in about a second, oh look, these are not empty desert to blue buildings, this is empty desert looking oceans to blue oceans. So, yeah, the laws of demos. There's farmland. All right, let's try, somebody yell something out for me to look for. Oh no, I know what I want to look for. I've got a good one. Let's look for construction site. Highway cloverleaf. All right, so this might be a construction site to a bridge. This might be a construction site going to a highway. Let's just find, look, this looks like a construction site which goes to a highway interchange. Let me like it. This definitely looks like a construction site that becomes more of a highway interchange. Let me like it. You know, it's a little bit spotty at the first time. Here's a construction site that goes to a highway interchange. That ought to be enough. Here's another construction site that's turning into a highway interchange. That's enough. 4 likes. It knows the embeddings of each of those tiles. It's going to form the average embedding. It's going to re-probe the database, and now it's going to just have them. That's pretty much 1 round of relevance feedback is usually all it takes. Yeah, all it takes. Did I do it? I have this feeling, yeah. Okay, now it's just finding, you know, construction site goes to highway cloverleaf, construction site goes to highway clover. You know, it's just finding it. It's just nailed it, just from a couple examples. The entire world, it just looked over the entire world at 2 different time points. Okay, each of these is about a square kilometer. Look at those beautiful things, isn't that nice? My sweaty hands are not. Anyway, we can just keep playing this game. We can do something harder. We can save the change, the things you're looking for. You can recall them back. I mean, like I've saved a few that are fun. Oops, let's just, I'm really having trouble because I'm sweating. All right, let's look for construction of large industrial facilities. And that's another one that starts with construction site, but nonetheless, boom, 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 boom. Oh, gosh, there's a really good one that people will love, which is, again, these were just text probes that I think this is construction of cooling towers. I'm going to zoom out again so I can actually see my menus. This will be the last one, Allison. Yeah, this is pretty crazy. Construction of cooling towers. Like, the fact that it can nail this. Oh, here it thinks they were constructed, but they just appeared from behind a cloud of steam. But like these were definitely constructed. These were definitely constructed. And this was done with a text probe with maybe 1 round of feedback, where it showed me a bunch of circular things that got built, and then I said, that's a cooling tower, that's a cooling tower, and then boom. So, you know, and then it starts to find things that eventually it may run out and find things that might not be cooling tower constructions, but are pretty close because they're round, or these things which might be sewage treatment tanks, or maybe beginnings of cooling towers. Anyway, it's getting there. And now, by the way, I can just click here, and it'll take me to our general chat with the Planet app, which will tell me for this location, oh, look, it's power technology, it's in China. it knows that they're cooling towers. It just immediately chatted me up about what I was looking at there, and then I can say, how long did this take? How long did it take for this to be constructed? And it can do its research and look at our older imagery, look in its weights. This is Claude behind the scenes here, but it doesn't have to be. And pausing for breath. Based on, here's what I can say, construction duration 2 to 3 years, so then I could go back, several years and see what it was like back then. And that's, it was just barren site, and maybe halfway through construction, what was it like? Oh, there it was snowy. Anyway, it's beautiful, and it's going to get more beautiful, and I'm happy to spend more time demoing with you all. Thank you for your attention.